Hello, everyone, and welcome to today's webinar, Making Art with Soul, the latest from Pixar's RenderMan. My name is Elise, and I am part of Foundry's industry marketing team, and it's my pleasure today to introduce to you my colleagues Gary Jones and Rory Woodford, as well as the Pixar Animation Studio team, Ryan Michero, Sarah Hutchinson, and Dylan Sisson. Our partnership with Foundry and RenderMan has been a great one, and we're really excited today to present the work that's been done on Soul and talk about our partnership. But first, I'll let Gary introduce himself.
Hi, everyone. I'm Gary Jones, the product manager for lighting at Foundry. I joined Foundry about 3 years ago again, having actually been there for Katana 1.0 all the way back. But during a brief hiatus while I actually worked in the industry, working on VFX heavy films. So it's great to be here again.
Hi everyone, I'm Rory. I'm the product manager for Look Dev at Foundry, looking after Mari and the Look development workflows in Katana. And before joining Foundry in 2016, I was working at VFX as a artist and pipeline TD for the S department, doing all kinds of things Mari, Katana, and Nuke related.
Hi, I'm Ryan Michero. I'm a lighting lead at Pixar Animation Studios. I joined about 6 years ago. Prior to that, I have about a little over 20 years of experience in the computer graphics industry. We stayed mostly on the animation side of things. So yeah, happy to be here today.
Great. I'm Sarah Hutchinson. I'm the developer for RenderMan for Katana. I've been with Pixar for almost 6 years, I think. And yeah, happy to be here today too.
Hi, I'm Dylan Sisson, and I'm a digital artist on the RenderMan group, where I manage the marketing. I started at Pixar in 1999, and today I'm here to host the Q&A. So there you go.
Perfect. Thank you for that. Before we move on, I just want to go over some quick housekeeping as well. To start off, today's session is being recorded, and a link of the recording will be sent directly to you. Also, the main presentations, they've been pre-recorded for streaming quality purposes, but will be available in the chat. So just letting you know about that. And then also the session will be wrapping with a live Q&A. So if there's anything that you would like to ask the speakers, please just add your questions into the questions tab on the right-hand side of the screen. So today's webinar is part of Foundry's larger virtual event series. And we started this about a year ago, and we hosted 80 events since. All of our events are available on demand on YouTube or our live stream page. And our upcoming schedule includes a Nuke CG and deep compositing workshop that Hugo Guerra will be streaming on his YouTube channel. And then also on May 27th, the MPC episodic team will be presenting a VFX breakdown of the third day. And Jellyfish Pictures will be joining us on June 3rd to present How to Train Your Dragon Homecoming. If you have any feedback on our virtual events or would like to join us on stage, please feel free to reach out to us at virtual.events@foundry.com. I'd also like to take this opportunity to mention Foundry Learn. On our Foundry Learn site, you can find tutorials, developer docs, release notes, and more for all of our products. And here are just a few examples of the tutorials that we have available. Gary will share a link to the page in the chat if you'd like to check that out. And while you're on our website, I'd also like to encourage you to check out our Insights Hub. On the Insights Hub, you can find articles, case studies, and artist spotlights, and things about the latest industry trends. So if you're interested in reading about that, check out our Insights Hub. We also have a quarterly newsletter that you can subscribe to. And if you are on social media, I'd also like to encourage you to follow us at the Foundry team or at Foundry team to stay up to date with the latest Foundry news. And finally, I'd just like to say thank you to everybody who has joined us so far this year. We couldn't do it without your contributions, and we are very thankful. And we look forward to working with you in the future and bringing more great content. Also, I'd like to thank everyone for joining today's webinar. We're looking forward to a great event, and I hope you enjoy. So with that, we'll pass it over to Rory and get it started.
Hi everyone. I wanted to quickly update you on some of the work we have planned for our Mari and Katana releases this year. For Mari, we're putting a lot of effort into Mari's quality of life. To start, Mari 4.7 v3 is going to be polishing the artist friendliness of color space workflows. This includes a new scalar color picking mode to allow artists to pick raw RGB values without Mari engaging our perceptual color picking engine. We're also adding some new nodes to the node graph to help artists visualize their networks in both a color and scalar context, as well as 2 conversion filters from color to scalar and scalar to color for those instances where you want the perceptual mid-gray of your roughness map integrated into a color channel. Back in Foundry Live, I mentioned that our brush engine has received an upgrade. We will now be able to control the color of each brush splat into the paint buffer. With extensive range controls for hue, saturation, and value jittering, artists will be able to achieve a far more stylistic brushstroke than ever before. With Mari's push towards USD integration, we're introducing the USD preview surface as a new shader type in Mari, with a plan to allow artists to export preview looks from Mari as USD shade documents at the end of the year. Artists will be able to populate Hydra viewers with richer-looking characters, vehicles, and environments authored in Mari. Beyond this year's goals, our vision is to have Mari become the first step in look development, leveraging the USD format to enable the artist to author object material assignments using selection groups directly within Mari. We see Mari as having a bright future in USD-powered studio pipelines. With regards to Katana look development, this year we're focusing on our network material interface. We're planning to bring some artist-focused polish to the user experience and expand on customizable user workflows. Keep an eye on us for more details as we get closer to our release later this year. I now pass over to Gary to talk about some Katana lighting features we have in the works.
So I'd just like to talk quickly about 2 items that we have planned for the release at the end of the year. So the first one is built around the Foresight tool that we shipped in Katana 4.0. And as you can see here, I've got 2 renders running from my little laptop. Imagine this could be 20 shots that you have sitting on the farm, all streaming back into your catalogue. That was all working in Katana 4.0. And here you can see me making a lighting change that is at a sequence-based level, and it's actually updating across multiple renders. Now, one of the restrictions of what we did in Katana 4.0 was that you couldn't do shot-specific overrides. But we're going to be changing that in Katana 5.0. So here what you can see is I'm just going to adopt this one for editing and mean that now I can start making individual light changes for a specific shot. So just going to cool this one up, make it a little bit cooler in terms of temperature. Please don't judge my lighting. And as you can see, there's no updates, no changes, nothing happening to the other render. That just carries on, oblivious while you're making your change to this specific one. So really nice, and it means that you can now do not just your overall sequence-based changes, but also your individual shot-based changes as well. So you could literally start off 20 renders at the start of the day and just tweak them and finesse them all throughout the day. So really exciting. The next block of work that I'd like to talk about is something that we are uniquely positioned at Foundry to do. So a lot of our customers entrust us with large areas of their pipeline, all the way from pre-production with flicks, right up to finishing from Nuke. So if you imagine, this gives us an awful lot of opportunities to do interoperability between those different products. And that's a real big theme of what we're going to be trying to achieve this year. One of the main parts of that is Katana to Nuke interop. And here you can see you're doing lighting, making all of your changes in Katana on the right hand side. That's being fed directly into Nuke on the left. It's going through a comping process, and then the finish of that comping process is going back to Katana. So exactly what this is going to look like, whether you'd be spinning up a version of Nuke that is live and open like you see here, or whether there's going to be it set up like a service, so you can set it and put the Nuke comp going on the farm to reduce the resources on your and the load on your local machine. Still to be decided, but it's a really exciting block of work that we're looking forward to. So imagine if you combine the two of those, you could be working on 20 shots, all producing lots of images, streaming them all to Nuke comps, and seeing them all in final shot context just there in your machine, and enabling you to have real confidence that you're actually achieving something that is exactly what your VFX supervisor is going to need. So really exciting. And now I'm going to throw it over to the Pixar team. Thanks.
Hello, my name is Ryan Michero, and I was one of the lighting leads on the Disney Pixar feature film Soul. I was specifically responsible for the Soul World assets from a lighting perspective, particularly the sole characters in the film. Like a jazz virtuoso, blazing through a dizzying solo, the talented and hardworking lighters on the film Soul were able to use their instruments, the Pixar lighting pipeline, built on Katana, RenderMan, and Nuke, to craft rich imagery that helps tell the story of the life of Joe Gardner as a musician and teacher in New York City. Our approach to lighting the real world of New York City was not fundamentally different to that used on other recent Pixar films. We start with a foundation rig that includes a distant light sun and dome lights for the sky and practical lights built into the sets. And then we may add movie lights, like this overhead key light to light up the area of interest. We may add a bounce light from the floor to fill in the characters' faces from below, and a stronger rim light from behind, motivated by the windows, to separate Curly and Joe from the background. And here's what the finished shot looks like. Because of the physically based lighting and rendering environment in RenderMan's RAS and our Katana toolkit, we work in an intuitive way that is not that different from what lighters would do on a live-action set, except that we can cheat a lot more. With direction by our lighting DP, Ian McGibbon, a sophisticated and mature toolkit, and an experienced and talented crew, the lighting team crafted pitch-perfect imagery for the New York City scenes in Seoul. But what if I told you that one of our biggest challenges, the one that vexed some of the smartest minds in the studio, that required new infrastructure that we wondered if we could actually pull off, was achieving this. You're looking at an early storyboard sketch of a Soul character from our director Pete Docter that became a touchstone image when we started our journey to determine what exactly the Soul characters were going to look like on screen. Taking a step back, one of the fundamental guiding principles of artistic direction from our production designer Steve Pilcher was to contrast the hard, tactile, textural, photographic world of New York City with a Soul world that was soft, ethereal, fuzzy, and painterly. We knew that Soul characters themselves needed a contrast from our human characters to support this idea. From looking at the concept designs from our Soul art team and thinking about how we would need to create cinematic imagery for shots in the film, we in lighting came up with some guiding principles for how we wanted to approach these characters. Our goals for lighting, then, were to develop a visual language for how these characters look. We wanted the characters to not be emissive light bulbs, but would need to respond to actual incoming light or be lightable themselves. And we knew we needed the ability to use light and shadow to define character shape and give depth and richness to the imagery. But soon we were faced with some very fundamental questions we don't have to worry about when lighting humans in New York City. How do you even light these things? What is their material? What are they made out of? Volumes or surfaces? What would the material's local color be, and would it even have an innate local color? How would light interact with this medium? There were a lot of questions, and we knew we quickly needed to find an approach for lighting these things, to take a stab at answers to the questions we had, to test some things and iterate on different approaches until we found a look that was workable. One of the fundamental ideas that guided us in the beginning, which came from our art director Brendan McGeary, was to have light drive the color of the character and have the medium change the color of the light over distance or depth. One type of material like this that inspired us was opalescent glass, which you can see here as it changes the color of the white light as it scatters through the volume. But this glass definitely looks like a solid object, and remember, our Soul world needed to be more ethereal. So we thought, what if we tried to make something that behaves like opalescent glass, but is a soft and ethereal volume? Starting down this path, our characters team took our working character rig, passed it through our usual shot conversion pipeline to generate surfaces stored in USD files, but then took the resultant deforming surfaces of the characters to which we would normally bind shaders and then light, and instead filled them with voxels through complex networks in Houdini, exporting them to Field 3D files and then loading them into Katana for lighting. These volumetric characters provided us something to start our visual development. Now we had something to work with, and here I'll be showing a few milestone takes out of the hundreds of takes made across our look development journey to illustrate some of the steps we took in finding the rendered look. Taking the physical nature of the opalescent glass material effect as a starting point, we experimented with trying to use our standard physically based Hinier-Greenstein-based volume shader as is to see what we could get out of it, starting with a fairly neutral albedo and changing the extinction color parameter to achieve a hue shifting effect like opalescent glass. PRMan's RAS mode is designed for physically based rendering, so if we could achieve something we liked with physical parameters, it would be like swimming with the current. And if we found the right numbers for a physical approach, we thought it might be relatively simple to shade and light these characters. However, we found it was very difficult and unintuitive for an artist to hit any art-directed colors with this method, and we ended up with dark and dirty colors on the shadow side. Ultimately, the look was too smoky and unappealing. Moving away from the purely physical method a bit, we sought to counteract the natural physical darkening of the shadows by lightening the volume's albedo color overall and boosting the transmitted light as it was attenuated by the volumetric self-shadowing, essentially fighting against the natural shadowing. And we attempted to enhance the light shaping of the character by simply making the volume denser. While we were able to make the character look more colorful and appealing, and we could definitely read the facial acting better, our creative leadership felt like this wasn't achieving their visual goals. More density made it not ethereal enough, and gave it the quality of a highly subsurface scattering surface, or marzipan, as Steve Pilcher, our production designer, called it. So at this point it was clear that using physically based extinction was not going to give us the look and control that we needed, and we were going to have to rely more on non-physical techniques. But we were still holding on to the core idea that the light would define the color, and that the color would change over distance or depth. Concurrently, the ideas from the art department were evolving, as seen in this painting, and we started to coalesce around a new visual approach. What if the color of the characters behaved more like the dispersion of white light into different frequencies of colored light across a medium, less like literal opalescent glass, and more like how water droplets split sunlight into a rainbow? So we started experimenting with pure rainbow color maps. The test seen here used a character with a white albedo and color totally defined by the light through a light filter plugged into the light color, the filter being essentially a 3D color field constrained to the head of the character, with the same spatial color ramp shared across multiple lights. We were able to get extremely vibrant colors, and the volume was feeling ethereal again, but we weren't really any closer to achieving the visual language we were searching for. This just looked too flatly lit, with little if any shaping in the face, and there was little reason to use lights, as this could be achieved with simple emissive glow. We also knew from the start that this prototype technique was too limited. You can see the rainbow color field locked to 22's head, pushing the color of the body into the blue hues as her head moves forward. So we knew we needed something colorful like this rainbow coloration, but we needed to get more shaping out of the characters. Going back to the drawing board with these ideas, our director of photography, Ian McGibbon, came up with this color key painting, which represented a breakthrough for us. It definitely felt like the color of Soul Joe here was coming from the light. The warm color of the rainbow was on the key side, facing the light. Cool colors were on the shadow side, and importantly, the blue side really felt like shadow. The rest of the rainbow cycle fell in the middle. This was the start of really determining the visual language of our character lighting, and we had a strong concept for what the character should look like when backlit. So the question became, how do we achieve this in 3D for a character seen from all angles? Our next attempts, trying to expand on the backlit nature of the breakthrough painting, used anisotropic forward scattering biased settings for our volume shader, meaning a light from behind the character would scatter more light in the direction of the light itself towards the camera. We were able to achieve some interesting shaping while still keeping the characters soft and ethereal as well as very colorful. But it was very difficult to read shaping on the face that would be critical for reading the facial animation. And as you can see for the bottom example, it was difficult to maintain consistent illumination on characters in motion as the shading was very sensitive to light placement, and the bounce made it too easy to wash out the vibrant colors. But from there, we were able to drill down on the designs, do paint-overs on the renders, and start finally realizing what we wanted the characters to look like in shots. This is a paint-over from a working section with director Pete Docter. In this, there is a feeling of the character responding to light from the front rather than the back. The color started moving away from the ultra-saturated rainbow palette into something more subtle, and biased toward the center of the rainbow, dominated with desaturated green and cyan hues. With the saturated reds and yellows and the blues and the purples pushed to the very edges, it still felt very soft and ethereal, and there was an almost diffuse quality to the shading, as you can see in the face, chest, and arms. There is the feeling of shadow, for instance under the chin to the left, but the shadows are still colorful, as if in shadow the base color of the character simply gets more saturated and dark. From here, the elements of the characters were starting to lock into place. As I mentioned earlier, the final characters are mostly made out of volumes, but there is one exception to that rule, and that is what are often called the windows to the soul, the eyes. Of course, it was absolutely essential to get the eyes right, as they are key to character appeal and emotion. Pete Docter was very clear that while the body should be blurry and soft overall, the eyes would need to be sharper and clearer so that we could better read the acting. The eyes would have to serve as an anchor of focus for these disembodied souls. After some experimentation with volumetric eyes, it became clear that we would need to keep the eyes as surfaces embedded in the volumes. This worked out well for lighting, as we could use, with few modifications, light rigs and shaders for the usual surface-based eye geometry developed across multiple other Pixar films. So instead of making volumes out of the eyeballs like we did for other surfaces, we lit and rendered the eyeball surfaces directly. But since the semi-transparent volumes of the head and eyelids did not fully occlude the eyeballs embedded in them, we had to make the eyeballs invisible except for the areas where the eyelids were opened. For this, we used a sequence of animated presence maps generated at conversion and hexport time. This generally worked well, though when the maps broke for whatever reason, it did lead to some funny-looking bug-eyed characters. And a critical finishing touch to the look of our characters is what our compositing lead, Jiaqi Hu, named the ethereal helmet. This was a visual element included in a lot of the concept art, including Pete's paintover, that seemed to be separate from the main substance of the character. And it consisted of a ring of vaporous, saturated color around the character's head. Initially, we were prototyped to look for this element in Nuke, using an ovoid shape constrained to the character's head in space, using a colorful texture for its color, and blurring and blending in the edges around the head. While some of the shots in the final film still use the new compositing-based ethereal helmet, we moved as quickly as possible to a system where separate volumes were generated within Houdini for the halo, so that there would be less bespoke compositing for every shot and every character in the frame. And this turntable of Soul 22 represents the final stage of our character look development. It still has an ethereal, soft feeling and does not have the overly dense marzipan feel. It responds to light mostly from the front, like a standard character, and the volume shader settings are dialed to be isotropic, essentially scattering light equally in all directions. The color is now defined as a property of the material, but designed to be tweaked by lighters through what we called the iridescence driver, a shading color generation node written by Junyi Ling, our character supervisor. The volumes store an attribute which is essentially a smooth normal from the surface version of the character, more on this in a moment, to use as a signal over which to modulate the color. The iridescence driver uses a point or coordinate system in space and creates a dot product with that surface normal attribute, which cycles through a color ramp as the normals smoothly turn away from that point. The lighters control the point in space, moving it to change directionality and create color shaping across the body, and the lighters had full control over the colors in the ramp and the spacing of the knots in the color spline. Additionally, in the iridescence driver, there is a faux shade lighting effect between the coordinate system and the transferred normals, giving us a fake diffuse and specular response to further enhance the shaping. And there is a new shadow tinting mode, which injects saturated color into the shadows as the shadowing of the key light gets stronger. Here's a visualization of the normals we transferred from the surface version of the character onto the volumes. We projected the normals of the front-facing side of the character straight through the character volume, so the normals from the back side of the characters wouldn't interfere with the clean and intuitive light shaping we could get from the front. This is to show how much we're getting out of the faux light layer of the iridescence driver, referencing those normals we project through the volume. On the left, we have all the elements of the shading with the faux light response removed, which gives a very flat green response. Once we added the full light response to the albedo, again, this was all in effect inside the color, not a BXDF, we were able to get a much more intuitive light shaping on the face. And this is a visual breakdown of what the set of shadow tinting shading features that were added by Julian Fong is contributing to Soul Joe. Julian's code allows us essentially to hijack the volumetric shadow signal, the shadowing of the light that is giving us accumulating darkness as the light penetrates deeper into the volume in the picture on the left, and we are replacing that shadow with a darker and more saturated version of the character's albedo coming from the iridescence driver. So we have a visual cue that behaves and feels like volumetric shadowing, but retains the vibrancy and saturation of the color that we were looking for. Here's a quick demonstration of everything working together and driven by a single 3D light in Katana through RenderMan's live render. The isotropic volume shading, the volumetric shadow color tint, and the rainbow light color ramp and faux lighting response coming from the iridescence driver. So far we've only been talking about lighting the soul characters with one light, and actually in a lot of cases in the movie this is really all that we needed. The single light response was designed to give us all the character shaping and color variation that we wanted, so for the vast majority of the shots we lit with these characters, they're generally lit with one single light. In fact, trying to light them with more than one light would cause problems for us, as it fought against our shading color design and shadow saturation effects, muddying up and confusing the look of the characters and very quickly flattening them out. But of course, there are some situations in cinematic character lighting where you really need to capture the influence of more than a single light. For example, when you have a character standing between the camera and a bright, practical light source, it just looks wrong if there's no rim light influence on the character from that light. So when we wanted to see the effect of a strong rim light on a soul character lit by a key from a different direction, we used a separate rim light pass. For this pass, the shader settings for the volume needed to be tweaked from their defaults to remove all of the shadow saturation features so critical to our look with our key lighting response, so that regular shadows could completely occlude the light behind the character from bleeding through and influencing the front of the face. Comp the rim light on top, and you have a believable rim light effect on our soul characters. This technique was used not just for rim lights, but for kick lights, bounce lights, even just to add more complexity and shaping from a slightly off-key direction. Katana and RenderMan gave us a platform with which we were able to do look development, light, and render these very unique characters and integrate them into the Pixar lighting process. Many more stories could be told about the implementation of these things in different parts of the Pixar pipeline and studio infrastructure, but today I hope I gave you a glimpse into how we got them working in lighting from a conceptual and practical standpoint, how we were able to do cinematic character lighting with what was essentially a fuzzy, ethereal mist. Thank you for your time today. Enjoy the Academy Award-winning Soul and its brand new follow-up short film 22 vs. Earth, both now streaming on Disney+. Now, Sarah Hutchinson is here to talk about the features and workflows enabled by the latest version of RenderMan.
Hello everyone, again I'm Sarah Hutchinson, the developer for RenderMan for Katana, and today I'll be letting you know about the new features that will be available in RenderMan 24. But first, some background for those who are new to RenderMan. What is RenderMan? Well, it's basically a means of translating your 3D scene full of geometry, lights, materials through a 3D camera. And the resulting image taken by that 3D camera is what we call a render. And you put those renders together and you have a film. RenderMan has been used to render all of our films, from the original Toy Story through Soul to everything in development, including Luca, which I recommend checking out when it comes out on June 18th. But of course, RenderMan is not just used at Pixar, it's also used throughout the industry to render feature film visual effects, including some of the ones that you can see here, our most recent films. And that's all great, but it's a little abstract. How do you actually work with RenderMan? Well, that is where RFK comes in. RenderMan for Katana gives you access to the full feature set of RenderMan, lights, shading plugins, cameras inside of Katana. So we'll have a quick overview of what that looks like with this teapot scene. In Katana, you've got your node graph that contains, gets turned into your scene, and then RenderMan will turn that into a render. Your geometry will come into your scene via limBegin or USDN. You can adjust depth of field or field of view on your camera via PRMN camera settings. The network material create node is a way to build up materials like what you see on the teapot here. We'll come back to that a little later. And you can manage lights in Gaffer 3 or adjust light parameters or create lights with the new Hydra Viewer lighting toolset. So let's talk a little bit about what's coming up next. RenderMan 24. It is already in beta and going to be released very soon, so stay tuned for that. The new features in RenderMan 24 are, first of all, we converted all of our existing patterns to OSL, and we also added some of the new ones that you see here, including bump to roughness, which is a pattern that lets you add scratches, fine details that actually affect the light response, not just the texture. And we also added other pipeline features like ACEs, a Blender plugin, and an updated statistics system, as well as adding features to improve the visual quality of our renders, like blue noise sampling. And all of those features were great on their own, but we have a few headline features: XPU, Lama, and stylized looks, and I'll spend a bit more time diving into each of these. So first up, XPU, what is that? Well, XPU is basically a new rendering architecture for RenderMan that will take advantage of all of the hardware on your machine, your CPU and GPUs. This was by far our biggest initiative for RenderMan 24, and we're very excited to get it out into the world. The first phase of development was focused on look development, so we're going to take a look a little bit at what that would look like inside of Katana with that teapot scene from before. So here you can see the shading network for the teapot, and we'll take a look at what it's like rendering in XPU. So you can see changing shader parameters, how quickly we get a response in the render. With that, you can do any of the same workflows that you would normally do when you're look deving. Disabling, enabling nodes works, or my favorite thing to do is mess around with displacement. So we've got a texture going into this unicorn, and you can adjust the scale of it, make something crazy or something more normal. We can go back to that. And XPU handles all that really quickly. Yeah, so it's on top of just the basic material edits. It also supports basic lighting setups and animation, so you can do things like turntables, which are essential for a look dev workflow. Yeah, so it's great to see this in action, but in order to see the full extent of why we put so much effort into XPU when we already had a working render RIS, we should take some look at a few comparisons. So, showdown time. First test here is going to compare the iteration speed, so the amount of time that it takes for the image to completely fill with pixels for a render. So we've got RIS on the left and XPU on the right. So once I press the big red button, we will see how they compare. All right, ready, go. Okay, so did you catch that? Even if you didn't catch it, you can see clearly that the XPU image will converge much faster compared to the RIS image because the speed of iterations is just so much quicker. And here's a freeze frame, just in case you couldn't see. You can easily see how XPU finishes the full frame while RES is still working and chugging along. So we're impressed with that speed. Here's a use case for look development, so you can see the advantage of the faster iteration speed here. As changes happen in XPU, you get a quick full frame update while RES is still slowly chugging along, adding all the new pixels. Here, those scenes were pretty simple, so we're going to look at a larger scene now. This has 378 unique objects, 7 million polys, so it's a bigger scene, and we'll get an idea of how XPU can scale. So there you go. We've got the teapots on a little lighting stage, and you can see that XPU scales and gives you an opportunity to see your look dev lighting in context in a larger scene. And another usage case is animation. So while XPU is focused on look development, you can see that it's also could be useful for playback or looking at volume render simulations, that kind of thing. And we're still expanding on the XPU feature set, so keep your eye on it for as more gets added in the future. All right, next, let's talk about Lama. What is that? Lama stands for layered material, and it's a material system created by our sibling studio, ILM. So it is a way of creating physical materials that are layer-based, and we'll see a little bit more about it here. So in Lama, there are a set of different VXDFs, diffuse, subsurface, emission, and then there's a set of tools for layering and mixing your VXDFs to make a larger shading network. So it can replicate a larger Uber shader, but it is got a more simple modular nodes. So let's take a look at that inside of Katana. Here we go. We've got a car here, and we're looking at the car paint shader. You can see just by looking at the material network what kind of material is getting produced. So here it's got a Lama dielectric node that's layered on top of a base that has diffuse material that is mixed with two different conductors. So you get an idea that this is probably a metallic, but not too metallic, shiny surface. The beauty of Lama is that it's really easy to take it apart and use just different pieces of it. So here you can see that you can just look at what the dielectric looks like, what the diffuse looks like. Each node here can be used on its own, or it can be combined to the larger material network here. So it's easy to debug and to diagnose while you're look deving something, just exactly what each component or combination of subcomponents is doing. And you can combine all of that into a larger network to get, as we see here, a nice shiny car. Note that that Lama is currently only supported for RAS, but XPU support is planned in a future release. And finally, last but not least, let's talk about stylized looks. So what does that mean? Well, it is an approach for creating new kinds of images. We're used to seeing shiny cars, you know, very standard visual effects, but this is a way to take advantage of what's already available in RenderMan to produce non-photorealistic images like those that you see here. these are all renders that are based on the simple geometry that you see there. And the tools provide ways to create many different looks using the same basic infrastructure. So it's easy to imagine trying to match any number of art styles, and it's a new tool, and we're excited to see what you can do with it. So for now, let's take a look at what it would look like in Katana. Okay, so in Katana, simple stylized looks can be provided with the PRMan stylized looks macro. This node provides all of the settings that you can see here that are used to create this sort of halftone ship in the scene. But of course, it's possible to create a more complicated pipeline using the same techniques. So looking inside that, you can see that it requires a set of AOVs, a set of display filters. A hatching, lines, and tune display filter are the options that we have, but they can be used in different ways, combined in different ways. And also a Pixar stylized control pattern that can be applied to different objects in your scene. So let's start by taking a look at the hatching display filter and what that does. So that is the way that we have the sort of halftone dots on this image. As you can see, this is a live render, and because stylized looks is embedded within RenderMan, we're able to get these sort of stylized looks without having to go through comp or anything. So we can see the changes update live. We ship with a standard texture set that has a bunch of different looks, and you can also add your own sets of textures. There's a custom texture set option, or you can set 8 individual textures to get the sort of gradation looks that you see here. All right, next we'll talk about more ways that you can customize your look. This is the lines display filter, so it's got the outlines here and the line thickness. You can either drive it from just a float value, or you can drive it from the Pixar stylized look pattern, the Pixar stylized control pattern. So that has lots of different settings. It can be set per object in your scene. It could be set to vary the line color, but in this case we're just varying the line thickness using a whirly pattern, and it's a way to give just a different look and feel to your line weight there. So there's a lot of more features on this than I could possibly talk about, but we really encourage you to check it out for yourself and see what you can come up with. And that is it. So thank you for joining us and hearing about Soul and about RenderMan 24. We're excited about the new features that are available, and we hope that you give it a try. So keep your eyes out for when it comes out later this month. And if you haven't checked out Soul yet, also give that a watch. Up next, we've got some Q&A with myself and with Ryan, moderated by Dylan.
Wow, those were great presentations.
Thank you.
Thank you.
Yeah, I learned a lot. Hey guys. So to kick off the Q&A, I guess we're going to be talking a little bit about what we just presented. I just wanted to reiterate that we are going to be launching RenderMan 24 this month. Date to be announced, but we're going to be basically landing the big project that's been XPU, and that's going to come in. We're excited to get it into the hands of our customers, and particularly into the hands of our customers with some of these new features in Katana, like foresight with the multiple renderers and shot-specific changes. I guess just to kick things off, I'll kick this over to Gary. How do you see XPU really what kind of synergies do you see that with the multi-shot rendering?
I think that XPU is probably one of the most exciting things out of RenderMan for a while. Just that iteration time. It's all about things. It combines the two things. It's about reducing the time to get to where you need to be to finish the shot, and to get to having the confidence that you've got what you need. With XPU, you'll get it for individual shots, but when you combine that with Foresight, you can get it across entire sequences. So you'll be there, you'll be getting iterations so much faster, and being able to see 20 shots all at the same time, getting to a really, really fast iterative process. It's a really exciting time to be doing lighting. I kind of wish I was back doing it myself right now. So I'm jealous of Ryan getting to play with this all the time. So yeah, really exciting time to be a lighter.
Yeah, it puts the fun back in rendering. So we're excited about that. Did any of the speakers have any questions? Did anybody, Rory, Gary, do you have a question for Ryan or Sarah, or before we jump into the audience questions?
I was actually looking at one of the audience questions, and it was exactly what I was thinking when I was watching the presentation. I was curious how the hands and the lines around the hands was done. Was that something that was a post-process in Nuke? Was it something that you had as part of the look? Really, really curious, because it looked amazing, and the way it blended as it went behind the character as well. There was some really nice effects with that. So can you shed any light on that?
Yeah, I'd love to. I'm glad that is coming up, because I had a bit in my presentation that I had to cut for time. But yeah, the line work was definitely something we needed, especially for the face. It was always difficult to get shaping out of the face. So we had sort of 3 different things that we did for the line work. We had silhouette lines and facial rig lines. And those were all in the rig, the animation rig, and controlled by the animator. So it was very sort of painstaking work for the animators to, there were some automatic things, like when there would be like compression lines from like somebody making a certain face, then like a line would show up, like this geometric line. But then it could be turned on and off and tweaked by the animators. But what you specifically mentioned, the hand lines, those were done in Houdini, and they were silhouette lines. And, like I mentioned, it was very complex networks of things going on to control those lines. And we actually had some custom Houdini nodes written by one of our tools developers that made those outlines, and it was very painstakingly, tweaked to do kind of the outline of the hands. And the hands lines were always turned off, but the silhouette body lines and the eyes lines were all controlled by the animators. And what we did is in Houdini it would create geometry, but then he would create the network, and Houdini would create volumes for them, and those were actually volumetric voxels that are lit, that we're looking at. And they had a very, very simple shader on them. They actually inherited a bit of color from, and it also got just, of course, natural bounce from diffuse bounce light and things like that. But yeah, those were lit, and yeah, those were all volumes. And of course, the sort of compositing and stuff, that's just sort of the natural. That's one of the reasons why we really, as much as we wanted like a cheaper, like surface-based rendering solution to this stuff, you just get that sort of beautiful transparency compositing all in render just from using volumes. So, yeah.
Cool.
Right, now I was going to ask, so you had volumetric, hard surface, and kind of not photoreal line work all together for the characters. how long did that take to iterate in the renderer when you were look deving that?
That was actually incredibly quick. The way that our pipeline that we did it, I think the big time-saving thing was that there was no density being live computed from a shader in the render. So that was all pre-computed in Houdini and then saved as a density attribute in the Field 3D file. So when our time to first bucket was, or time to first pixel, whatever, when you press render before you start seeing the image show up, it's maybe for like a single character and some stuff in the scene, it's, like a minute and a half, 2 minutes, something like that. It was really pretty fast, and it converged relatively quickly too. We were kind of all shocked of how smooth it was running and how quickly it was rendering, but I think that was due to the pre-computation decisions that we made early on in the process, and we never really had a big render time problem with those characters.
Were those techniques similar to how Reyes used to work back in the day?
I'm not sure what you're...
Before RAS, the REYES, like all the computed voxel type of techniques. So.
I'm not sure if that is what it is, but it was just that's just pretty.
It was quick. The technique was quick.
Yeah, it was pretty quick.
That's brilliant.
It's a fast renderer.
Yeah.
And speaking of fast renderers, we have a number of questions about XPU. I think this one encapsulates a bunch of them, so I'm going to pitch this over to Sarah. The question is from Gabrielle Arnold. Will XPU be limited to certain types of GPU? For example, does it only work with RTX cards? The advances look amazing. So,
yeah, it's a good question. It's a CUDA-based renderer, so it'll work with any CUDA supporting GPU. Yeah, we tested like those demos that I showed were using an RTX 6000 card.
And the more memory, the better, right?
Yeah, of course.
Yeah. So it's because it's really focused on production size scenes, and the architecture is geared for being able to push a lot of data into it. So you really want the best cards that you can get.
Yeah, but yeah, the beauty of XPU is it supports, it uses your CPU as well as your GPU. So even if you don't have the best card, you can still get some of the advantages of it.
And you can run it on the CPU too, if you want.
If you don't even have an XPU, yeah, you can. Yeah. For a GPU, you can run it on CPU.
And it's actually faster than RAS for a lot of scenes too. So here's one for the Foundry folks from Ravi. In Katana, we have light lists which can give all the lists of lights for editing?
So I'm going to use a Pixar film as an example of the way that we tend to do our solution. So if you think of a film like Coco, where the underworld, or whatever you want to, the place for the dead, the amount of lights that might have been in that scene, having them all in a single light list would be very difficult. So what Katana actually has is it has a Gaffer 3 node, which is the standard place where you do most of your light editing, and you can point it at a location and it will show you the lights that are inside that location. So if you may imagine you had 2,000 lights in a Coco scene and they were hierarchically represented, you could say the section that you care about may only have 50 lights, and you point your Gaffer 3 at that and it will list all of the lights that are inside that, and then you can decide exactly how you want to make edits specific to that particular group of lights, whether it's across all of them because they're sharing something like a template material, or on individual lights as well. So we don't use a light list per se, but it's kind of got that sort of behavior built in with the Gaffer 3, and that's where that's kind of your workhorse for your lighting inside Katana. hopefully that answers your question.
I think that was great. And Coco's a good example. Some of the scenes in Coco had over 8 million lights, which is a lot.
That's quite a bit.
That's quite
I'm hoping
a bit.
there's some instancing being used there.
Sometimes. And here's one for Sarah. This is related to Llama, and Michero asks, does RenderMan 24 have support for Material X?
Yeah, so we are hoping to support Material X in the future, and we're hoping to use Llama to do that as a way to bridge between Material X. But RenderMan 24 itself doesn't read native Material X stuff. But yes.
Stay tuned.
Stay tuned.
Yes. Great. And we have another interesting question for Sarah related to XPU. Can you talk about the integrators that are supported in XPU?
Yeah, I'm not sure exactly which ones are supported, but normally integrators are a plugin with RAS, but in XPU we have a version of Pixar Path Tracer that is supported for sure. I'm not sure if there are other ones that are supported. Do you know, Dylan?
I think Path Tracer is the one that's
right now.
going to be supported in 24, and maybe more to come in the future. Yeah. And then we have a couple other ones. This one's from Eugene. He says, stylized looks amazing. Does it work with animation? Also, how does it work with Pixar Surface?
Yeah. Okay, I'll give a little bit of information on that. So stylized looks can work with animation. There's, I didn't show it in the video, but I guess I could have. It uses, you can have different controls that will make it map onto your objects or map in screen space or, yeah. So there's a lot of control that you have with your looks. How does it work with Pixar Surface? So you can use that Pixar stylized control pattern to drive that into Pixar Surface, and you can control different aspects like the line color, the object color, the hatching color, all the things, a whole bunch of things, and also you can use it over Pixar Surface.
Are you saying that I can just have my shaders set up on my objects and then plug these stylized controllers into my pre-existing shaders?
Yes, you can.
That's cool.
Yeah.
And when I can control things in animation, I'm able to use the coordinate systems like in Katana and the familiar sorts of tools in the DCC to kind of project those in a way that I'm already used to for physically based rendering.
Yep, that's right. Yeah, it's really customizable, and we definitely encourage you to check it out once it's available.
Cool. And let's see, how are we doing with time? Do we have still a bunch of questions.
Time for one or two more, I think.
Time for one or two more. Okay, let's see. And here's one from Kadir, which I'm going to pitch to the Pixar folks and the Katana Foundry folks. Is stylized looks just for Katana, or will Nuke have that? Or can we render that stylized look from any other 3D software? I think there's kind of an interesting question here about how you can work interactively and then also write out AOVs for compositing. Maybe talk about that a little bit. Kick that off, Sarah.
Sure, yeah, I'll start that off. Yeah, so stylized looks, it works with a bunch of AOVs, and you can separate those out and render those out and then composite them in some way. with Nuke, but it also composites things automatically with the display filter within the render. But of course, there's more things you can do on top of that with compositing. Maybe someone else can take it from there.
Yeah, Gary, you're working on something.
Hi, yeah. So, I'd guess it'd work fairly similar to the way you think in terms of traditional compositing, right? So if you think about the way your diffuse, your specular, the way that your lights contribute, when you see your primary pass, you're seeing those all put together. But you would quite often send them as separate passes to comp because they'll finesse it and come up with a more specific look in comp. And it would be exactly the same with the stylized looks. You would get to see it all as like a beauty pass inside Katana with all of the different elements like the line work and the hatching and all the rest of it from the stylized look straight inside Katana. But if you wanted to finesse it, if you wanted to do something different inside of Nuke, you would have that option because you would be writing it out as separate AOVs. It's really exciting to be able to do that kind of new thing with RenderMan as well, to have that new tool in your arsenal. Really cool.
Cool. And then one final question. We're going to give this one to Ryan, and Hiram asks, I've always had trouble getting world position, vector, and normal data for VDB objects. It looks like you were using some kind of projection method to apply normals to the soul characters. Is this a default RenderMan or Pixar magic?
I'm afraid it's Pixar magic, actually. Or it's Houdini magic, actually, where we're doing, we were getting those normals in through our USD. We would process the models quite a bit in Houdini, and one of the things that we were doing is taking a render and of the normal maps essentially, and then projecting the attribute, the normals attribute through the volume completely, and that would be just like a full 3D field of normal attributes, which that lived inside the field 3D file, so that they could be accessed at render time. And so yeah, Pixar magic. It's not an out of the box kind of a thing, sadly.
Good to know. And on that note, I think this was a fun QA. It was a nice chatting about this technology with you folks. And anybody have any closing thoughts?
Just wanted to thank you all. Yeah, we're all looking forward to getting our hands on XPU, and just wanted to thank you all for coming and for some great presentations. Thank you, Ryan and Sarah and Dylan, for emceeing. Really appreciate it. Thanks everyone for joining.
Yeah, thanks, it was super fun.
Thanks.
Take care, everyone.